Here's an interesting problem. We have water leaking out of a tank at a certain rate. So we're measuring how fast the water is leaving the tank. And it depends on time. So I guess as time moves on, there's less water in the tank, thus less pressure, so the rate decreases. But regardless, we know how fast water is leaving the tank. It's at a rate where R, so the output of this rate is in milliliters, milliliters per hour. All right. And time is measured in hours. So everything checks out. Give the volume that leaked out of the tank in the first 3 hours. So this tells me integration, right? Because I have a rate and I want to go back to the actual amount of water. Right. I want to take this milliliters per hour and turn it into milliliters. So reminder, you can find the difference in a function by anti-differentiating the derivative of that function between the 2 points of interest, right? So we're going to anti-differentiate the rate and recover how much water changed, the leak. So with this in mind, that's where we should start. We should integrate the rate R of t as t moves from, where do I want to measure how much water leaks out? Oh, here, in the first 3 hours. So I want to integrate from 0 to 3 because time is measured in hours. So the first 0 hours and then 3 hours. This will be the integral from 0 to 3. R of t is 3 over t plus 1 plus 2. All right, so I need to find an antiderivative and evaluate it at the difference of 3 and 0. So this will anti-differentiate to 3 times the natural log of t plus 1 plus 2t, which we will then evaluate from time is equal to 0 to time is equal to 3. Okay. Now what? Now we just need to plug this in. So we'll take 3 times the natural log. If I plug time is equal to 3 into this equation, I would get 3 natural log absolute value 4, so just a 4, plus a 2 times a 3 is a 6. That's my antiderivative at the upper bound, and I'll subtract the antiderivative at 0. So that will be 3 times natural log. 0 plus 1 is 1, absolute value 1 is 1, plus 2 times 0, that's just 0. All right, so 3 times natural log of 4 plus 6 minus 3 times natural log of 1. Before we go to a calculator, natural log of 1 is just 0. So this is 3 times the natural log of 4 plus 6, which we can approximate to be about 10.16. So if the rate was in milliliters per hour, this is now just measured in milliliters. So 10.16 milliliters leaked out during the first 3 hours. All right. This question now, give the average leak rate between 3 and 7. So on average, between these two time or during this time interval, these 4 hours, how fast is the water leaking out? So I can find the average of the rate between 3 and 7 by 1 over 7 minus 3 times the integral from 3 to 7 of the rate. So this will be 1 over 4, and then the integral of the rate between 3 and 7, that was the first part of this question. We got 10.16. So this is no longer equal. We made an approximation. So if I take 1/4 of 10.16, I get 2.54. Cool. So on average, during those 4 hours, we're losing 2.54 milliliters per hour.